Welcome to today's deep dive. We are taking you on a journey today. Our mission today, and this is a structured learning experience for you, is to get you confidently translating everyday business questions into actual functioning SQL queries. And by the time we are done here, you will be pulling data, sorting it, filtering out the noise, and even building custom categories on the fly. And we are going to do it without you needing a computer science degree. Definitely not, because the secret is that writing code for a database isn't really about the typing. It's about the prep work. Okay, prep work. Yeah, before you even touch a keyboard, you really need to answer 5 questions for yourself. Think of it as a pre-flight checklist. I'm intrigued. What's on this checklist? So first, what database are you actually speaking to? Second, what specific table inside that database has the data you want? Right, you gotta know where to look. Exactly. Third, what exact fields or columns do you need to see? Fourth, are there any parameters to filter out the data you don't want? Okay, that's 4. And fifth, and honestly, this is the most critical one, what is the one-sentence summary of what your final result should look like? If you can't state your goal in one simple sentence, well, you just aren't ready to write the query. That makes a lot of sense. It really forces you to clarify your intent before you get lost in the code. Exactly. To make this really concrete for you listening, we're going to use a running scenario today. Let's imagine we've just been hired as data analysts for a fictional online music store called Stoons. Stoons, I love it. Yeah, so they sell digital tracks, full albums, they have thousands of customers globally, it's just a massive mountain of data. And our very first assignment from the boss is to pull a simple list of customer emails for a marketing campaign. So where do we even start? Strangely enough, we start with something the database is programmed to completely ignore. We start by writing a comment. In SQL, if you type 2 hyphens, anything you write after that on the same line is totally invisible to the computer. Or you can use a slash and an asterisk for a bigger block of text. Wait, if the database ignores it, why are we bothering to write it? For the humans. I mean, a comment is just a plain English sentence explaining your logic. You drop in your name, the date, and that one-sentence summary from our checklist. Oh, I see. We do this because it saves future you, or, whatever poor coworker inherits your file 6 months from now, from having to reverse engineer your entire thought process. Oh man, I have definitely been that poor coworker trying to untangle someone else's messy spreadsheet. Right. Leaving a breadcrumb trail is just common courtesy at that point. Okay, so we've written our comment. The system knows to ignore it. Now we actually need the data. Marketing wants first names, last names, and emails for all the existing customers. This is where we bring in the heavy lifters. The select and from clauses. The foundation. Exactly. First, we tell the database where to go. So we write from customers. That directs the system to the specific table. Then, right above that, we list what we want by writing select first name, last name, email. I always found that order a bit weird. When you read it aloud, you say select first, then from. But logically, wouldn't the database need to know the table before it knows what columns to grab? You've hit on a really common point of confusion there. Behind the scenes, the database engine actually does process the from clause first. Oh, it does. It locates the table, and then it processes the select clause to pluck out the columns. But, SQL was designed back in the 1970s to read like an English sentence, select these things from this place, so we type it in that order, even though the engine reads it differently. That is fascinating, and typing it brings up the issue of punctuation. I noticed you said first name, last name, email. The commas are obviously separating the fields. Right. But what if I'm typing fast, and I just sort of throw an extra comma at the very end of the list, like select first name, last name, email, comma. The database will immediately throw a syntax error and just refuse to run. But why? Why can't it just see that there's no word after the comma and ignore it? I mean, humans do that all the time with typos because of that relentless literalism we talked about earlier. To the database engine, a comma is a strict command that means I'm about to hand you another column name. Ah, I see. When it hits that final comma, it stops and waits. When it sees the from clause next instead of column name, it panics. It doesn't guess your intent, it just fails. Wow. Okay, so no rogue commas at the end of lists. Got it. Now, assuming I typed it perfectly, I get my list back. But sometimes, the people who built the database use terrible naming conventions. Oh, absolutely. Like, the column might be called cust_f_nm_01. If I hand that to the marketing director, she's going to ask me what language I'm speaking. Which is exactly why we use aliases. You can cosmetically rename any column right in your query using the AS keyword. Okay, how does that look? Instead of just selecting first name, you write first name AS. and then bracket, first name bracket, with a space in between the words. The brackets tell the system to treat the space as part of the new name. Wait, does that overwrite the actual database? Like, will the database engineers be furious with me for changing their table? Not at all. It's completely non-destructive. You are only renaming the column in your temporary viewing window. The underlying architecture of students is perfectly safe. Okay, that is a huge relief. So, I have my query, I pulled the names, I pulled the emails, I cleaned up the column headers, but if I just run select and from on a massive customer table, the output is going to be completely random, right? Just whatever order the accounts were created over the last 10 years. It will be a total jumbled mess. Yeah, it's a raw data dump. Right, and if I hand a 10,000 row unsorted spreadsheet to marketing, they aren't going to be thrilled. We definitely need to organize it. That requires the order by Y clause. This goes at the very end of your query. If you type order by last name, the database will automatically sort everything alphabetically from A to Z. And if I want it Z to A, you just add the abbreviation, DESC, for descending, right after the column name. So, or by last name DSC. The default is ascending, but you have full control. There's one tricky quirk to watch out for, though. Oh, what's the quirk? Empty values. In SQL, a completely blank cell is called a NULL value. It doesn't mean zero, it means unknown, or just nothing is here. Okay, if you sort a column in ascending order, A to Z, the database considers NUL to be the lowest possible value. So any customers who maybe forgot to enter a last name will suddenly float to the very top of your beautifully sorted list. Ah, so you start reading your report and the first 20 rows are just blank last names. That is annoying, but good to know, so I don't think I broke something. Now, what if the boss doesn't want all 10,000 customers? What if I just want a quick sample to see if the query works? Can I just ask for like 10 rows? You can by using the limit keyword at the absolute very end of your code. You just type limit 10. But you have to be incredibly careful about how you combine limit with order by Y. Okay, let's use an analogy for this because I know this is where a lot of beginners trip up. Imagine you walk up to a massive, chaotic desk covered in thousands of messy, disorganized files, just scattered everywhere. I could picture it. If you tell the database limit 10 without any sort of order, you are essentially just grabbing the top 10 files sitting on the closest pile. They are totally random, they mean nothing. Yeah, it's just the 10 files the database happened to stumble across first. Right. You always have to organize the desk before you grab the files. You have to tell the database to sort everything alphabetically or by price. That's your order by Y. And then you scoop the top 10 off that neatly organized stack. That is a perfect way to look at it. Let's pause for a formative check and actually test that logic. Let's do it. If the student's finance director came to you and said, I need to see the top 10 highest paying invoices we've ever had, how would you build that? Okay, let's think through the checklist. I'd select my fields, maybe the customer name and the invoice total. I'd pull it from the invoices table. Then, to organize the desk, I would order the invoice total. Right. But I'd need it in descending order, right? DESC, so the biggest numbers are sitting at the very top of the pile. And then, only then, I'd add limit 10 at the end to just grab those top 10 massive invoices. Exactly. You organize the desk, then you grab the files. Spot on. Okay, so we can pull data, we can sort it, we can limit the size of the return, but let's escalate the difficulty. Let's say Steams has 1 million customers, and I want to know how many customers live in Paris. That's a lot of scrolling. Yeah, I can't just sort by city and then manually scroll through 1 million rows until I hit the P's. If you've ever spent a Friday afternoon manually scrolling a spreadsheet looking for a specific value, you know how mind-numbing that is. It's an enormous waste of time. Yeah, we really need the database engine to do the heavy lifting for us here. We need to shift from just viewing the data to actively filtering it. Yeah, and that brings us to the where clause. I like to think of the where clause like a gold prospector sieve. You're shoveling all this raw dirt and rock, which is the full database, into the sieve. I like that visual. The where clause is the mesh screen. It lets all the useless sand fall through and wash away, and it only traps the specific gold nuggets you actually care about. That's a great analogy. And structurally, the where clause always lives right in the middle of your query. It sits after the from clause, but before the order by clause. You tell the table, you filter the data, and then you sort whatever's left over. So how do we actually write the filter? Well, the sieve operates using operators. There are a few different types. Let's start with arithmetic. You can actually do math inside your query using plus, minus, multiply, or divide. Wait, so if an invoice total is $1.98 and the accounting team wants to see what that looks like with a 15% tax added on top, I don't have to export it to Excel to do the math. I can just type select total asterisk 1.5 time. Yes, and the database calculates that new number instantly for all 1 million rows as it retrieves them. That is wild. But wait, does that change the actual invoice in the system to include the tax? No, just like the aliases we talked about. It is completely dynamic. It calculates it on the fly for your results screen, leaving the original data completely untouched. Beyond math, we have logical operators. What if we want to find invoices that fall within a specific price range? Let's say everything between $2 and $5. I'm guessing we use the word between. You do. You would write where total between 2.0 and 5000. The important thing to know about between is that it is inclusive. It will grab the exact $2 invoices, the exact $5 invoices, and every single penny in the middle. Got it. What if I only want very specific disjointed numbers? Like I only want to see invoices that are exactly $1.98 or exactly $3.96 and absolute nothing else. Then you trade between for the in operator. You write where total in, and then open a set of parentheses and list your exact values separated by commas. So parentheses of 1.98, comma 3.96, close parentheses. It will only catch those exact matches. Okay, that handles numbers nicely. But what about text? Like finding those customers in Paris or finding people whose last names start with a B? How does the sieve filter text? For text, we use the like operator, and we almost always pair it with a wildcard. The most common wildcard in SQL is the percent sign. How does a percent sign act as a wildcard? The easiest way to understand the percent sign is to translate it as the database saying, I do not care what else is here. It's a placeholder for any number of characters. 0 characters, 5 characters, 50 characters. Let me test this. If I want to find all customers whose last name starts with B, I would write where last name like, quote, B percent sign, end quote. Because I'm saying it must start with a B, and after that, well, I don't care what comes next. Spot on. What if I want a name that ends in son, like Johnson or Harrison? Would it be like percent sign son? Meaning, I don't care what the first part is, just make sure the last 3 letters are S-O-N. Yes. And if you put the percent sign on both sides, like percent sign, T percent sign, you are telling the system, I don't care what is at the beginning, I don't care what is at the end, just find me T somewhere in the middle. Oh, that was so useful. And one very helpful note here, these wildcard text searches are generally not case sensitive. It will find both uppercase and lowercase t's. So wildcards are incredible when you only have a fuzzy idea of what you are looking for. Now, this brings us to a trap. A massive logic trap that almost everyone falls into when they start combining these filters. The and or trap. Yes, this is where human language and machine logic just completely collide. Okay, let me set up the scenario for you listening. We want to find students' invoices that are over $1.98, but we only want them from billing cities that start with the letter P or the letter D. Paris, Dublin, Prague, you get the idea. It's a very standard business request. Combine a price filter with a location filter. Right, so if I'm just translating that thought straight from English into SQL, I would write it left to right, where total is greater than 1.98 and billing city like P%, or billing city like D%. Makes sense in English. Yeah, in English, if I tell a travel agent I want a cheap flight to Paris or Dublin, they understand that I want both options to be cheap. They don't mean a cheap flight to Paris or literally any flight to Dublin, even if it costs $10,000. But the travel agent understands context. SQL does not. If you run that code exactly as you typed it, you will get a completely compromised set of data back. Okay, break down the mechanism for me. Why does the database misunderstand that query? Because SQL processes logic the exact same way it processes mathematics. Think back to middle school algebra, BEDMOS, or PIMDAS, the order of operations. Oh wow, parentheses, exponents, multiplication, division, addition, subtraction. Exactly. SQL treats the and operator like multiplication, and it treats the OR operator like addition. According to the rules of math, multiplication always happens before addition. Yeah, so the database engine reads your query and forcefully groups the A&D section together first. It says step 1, find me all the invoices over $1.98 from cities starting with P. Okay, so far that's actually what I want. But then it moves to step 2. It sees the OR operator. And because OR is treated as a completely separate secondary operation, the system says, OR, just grab every single D city in the entire database. Oh, it completely detaches the D cities from the $1.98 price rule. You will get Dublin invoices for 99 cents mixed right into your result, ruining your entire report. Oh, because the $1.98 rule was only glued to the P cities by the A&D operator, the D cities were just floated out there on their own. So how do we force the database to apply the price rule to both sets of cities. You have to corral your logic using parentheses. Just like in an algebra equation, you have to tell the database what to group together. Okay, what does that look like? The correct way to write it is, where total is greater than 1.98 and D, then you open a parenthesis, billing city like P%, or billing city like D%, and then close the parenthesis. That makes total sense. Now, the database has to look inside the parentheses first. It gathers a big pile of all the P cities and D cities. Then, once it has that specific pile, it applies the $1.98 minimum to the whole group. Using parentheses whenever you mix A and D and OR is literally the only way to guarantee the machine is actually executing your human intent. It's amazing how literal it is. Okay, so we now have this pinpoint accuracy to find exactly what we want. We sifted out the sand, we have the gold nuggets. But what if we want to take this raw, filtered data and build entirely new custom categories for our business teams? This takes us into a slightly more advanced application, the Casey statement. Here's the scenario for this one. The student sales team wants a new report. They don't want raw invoice totals anymore. They want all purchases grouped into distinct tiers. Yeah. If an invoice is under $2, they want it labeled as a baseline purchase. Between $2 and $6.99 is a low purchase. Between $7 and $15 is a target purchase. And anything above $15 is a top performer. So we are categorizing continuous numeric data into discrete buckets. The case statement is designed perfectly for this. But the first thing you need to know is where it actually goes. Where does it go? Well, a lot of people try to put it in the where clause because it involves conditions. It actually lives back up at the very top inside the select clause, right alongside your regular columns. Because we are essentially selecting a column that doesn't exist yet. We are inventing a new column of data. How does the database engine actually process a case statement behind the scenes? It evaluates the data row by row. It looks at the first invoice. It checks your first condition. When total is less than $2, then baseline purchase. If the invoice is the $1.50, the condition is true. The database slaps the label baseline purchase on that row and immediately moves to the next invoice. The invoice is $5. It fails that first test. Then the engine moves to your second condition. When total between $2 and $6.99, then low purchase. It sees that $5 fits, slaps the low purchase label on it, and moves on. You just stack these when and then statements logically. It's essentially just a chain of if this, then that questions. Yes, exactly. But there is one vital piece of syntax at the end. After you list all your specific when-in rules, you must include an ELSE keyword. What is the ELSE? ELS is your catch-all bucket. It's for any random outlier that slips through all your previous rules. So you would write ELSE top performers. And then you close the whole block with end as purchase type. Purchase type being the name we are giving to this newly invented column. What happens if I forget to type the ELSE line? If a row doesn't fit any of your when rules and you don't have an LSE bucket to catch it, the database will just label it NULL. It will just be a blank cell in your report. And we already know how annoying NOL values can be. I can hear someone listening to this asking, why write all this code? Why not just pull the raw numbers, export it to Excel, and use a pivot table or an IF statement over there? Because doing it in Excel breaks the chain of analysis. When you categorize the data dynamically within the database query, you can immediately pull secondary insights without ever leaving the system. Oh, like what? For instance, once we use the case statement to label those top performers, we can wrap that query in another query to find out what countries those top performers live in. Oh, so if the database tells us that 80% of our top performers are in Germany and Japan, the sales team can instantly pivot their ad spend to target those specific markets. Exactly. We didn't just move numbers around, we transformed raw data into an actual strategic insight, which is the entire goal of learning this. Let's synthesize the journey we took today. We started by translating human questions into select and from clauses, being very careful not to trip over rogue commas. We organized the messy desk of data using order of by before grabbing our specific samples with the limit clause. We used the gold prospector sieve the where clause to filter out the noise, using arithmetic, ranges, and wildcards. We learned how to avoid the and or trap by managing our logic with parentheses, remembering that the database thinks like a calculator, not an English speaker. And finally, we built custom dynamic business categories from scratch using case statements. You really have all the foundational blocks you need now. And the beauty of this is that SQL is universal. Whether you are querying a fictional music store or a massive real-world banking system, these exact rules apply. The grammar doesn't change, only the size of the tables.